blowing out a candle is so 2015. Here are 5 wacky ways to put out a candle. I've got here a tightly wound coil of solid copper that I'm gonna put over the top of the flame. It came back to life as soon as I took the coil off. It was smoking like the candle had gone out, and yet, poof, the flame comes back to life. I had to see this in slow motion. So there are a few things going on in this one, and it's really cool. Copper is one of the most thermally conductive metals, which means as I put it over the flame, it's taking away heat, which is one of the key ingredients that keeps a fire burning. But the other thing that's happening is that it's a pretty tight coil, so it's also depriving the flame of some oxygen, another key ingredient. As soon as I remove it, more oxygen goes in there and builds the fire back up, and the temperature can get higher again. But of course, if I deprive it of a lot of oxygen and a lot of heat, it will go out. I could just blow the candle out, but what if I put an obstacle in the way? I'm gonna blow around this glass, and the candle goes out. I put an obstacle in front of the candle, but it's rounded, so the path the air takes follows smoothly along and hits the candle in the back. This will even work with this jar of cashews because it's slightly rounded on the corners. Okay, I don't know about you, but this surprised me that this actually works. And what doesn't work is if you take a box like my candle box, which is square, has these rough corners, and try to blow past it. It just doesn't work, no matter how hard I try. Now you might say, well, the box is actually slightly wider than this cup, which is why I'm not able to blow around it. But what if I take this soccer ball, clearly wider than the box, and try to blow around the soccer ball? Okay, I couldn't see the moment when it happened, but this clearly shows that it's the rounded surface that makes all the difference. Fluid dynamics. For this one, I'm gonna snuff out the flame by putting a glass over the top. And now the explanation goes that the flame is using up all the oxygen inside, which is one of the key ingredients that keeps the flame going, so the candle goes out. But if that were the whole story, then this wouldn't work. I'm leaving a space, so there's no seal. Air could get in, but the candle is slowly going out. Poof! It goes out, which just goes to show you it's all about airflow. The hot air is rising up to the top of the cup, and that's air that doesn't have as much oxygen in it. It's not circulating and pushing in new air, and the candle can't burn. I've got a chunk of dry ice here, which is carbon dioxide cooled down to such a low temperature that it becomes a solid. And as the dry ice sublimates, that is, turns directly from a solid into a gas, it fills up this cup with carbon dioxide, which stays in the cup because it's more dense than air. So I can then pour it directly on the candle and put it out. So easy. And if you can't find any dry ice at a grocery store, you can do this one with the age-old ingredients, baking soda and vinegar. Take some of your baking soda and put it in the first cup. Pour a little bit of vinegar in there, wait till it fizzes, and you wanna make sure that these bubbles are filling all the way to the top of the cup. You don't want just a little carbon dioxide, you want the whole thing. Now this is my favorite part because it looks like you're doing absolutely nothing. You're gonna pretend to pour carbon dioxide, and unlike with the dry ice, you can't see anything happening. Now believe it or not, there is carbon dioxide in this cup. And now light your candle and put it out with your CO2. Candles out. Turn down the flame. This last experiment was mostly just for fun because we had some liquid nitrogen. We're gonna pour some of this liquid nitrogen over the candle and see if it puts it out. My prediction is it will. Liquid nitrogen is nitrogen cooled down to below negative 196 degrees Celsius, below the point where the gas condenses into a liquid.
What are we gonna do when we actually pour like liquid nitrogen on it?
I wanna freeze the wick. Ooh, I wonder if I could just pour it without Oh, you see that? We gotta light it again. So apparently, cold nitrogen gas is more dense than air, because before the liquid nitrogen could even hit the candle, the gas put out the flame. Well.
Alright, well that's well and dead.
But it was still pretty cool to watch what happens when liquid nitrogen freezes candle wax. That is intense. Look at the cracked melted wax on there. This is a cold candle. There you have it. You can pour out a candle with liquid nitrogen. Thanks to Derek Muller of Veritasium for filming that for me.
I'm ready.
And a word to the wise. I just spilled so much baking soda on the floor. Do this someplace where you can make a mess and where you're not gonna set anything else on fire. Thank you for watching this episode of Physics Girl. Subscribe if you want more physics, and happy physicsing.